We now discuss the solution of a problem from the section Differential Equations. This question is on an initial value problem. This question has appeared in the Joint Entrance Examination Main held on 26th June 2022 in the second shift. The given problem is if the solution of the differential equation dy by dx plus e power x into x square minus 2 into y is equal to x square minus 2x into x square minus 2 into e power 2x satisfies y at 0 is equal to 0, then the value of y at 2 is, we are given four options. Option A, minus 1. Option B, 1. Option C, 0. Option D, E. We are given this differential equation. It is given the solution of this differential equation satisfies y at 0 is equal to 0, required to find the value of y at 2. That's our given question. Let's now solve the differential equation in detail. The given differential equation is this one, dy by dx plus e power x multiplied by x square minus 2 multiplied by y is equal to x square minus 2x multiplied by x square minus 2 multiplied by e power 2x. With an initial condition y at 0 is equal to 0. A differential equation with a given initial condition is called the initial value problem. So this is a given initial value problem. So we have taken the differential equation and we observe that it is of the form dy by dx plus p of x multiplied by y is equal to q of x. It is in this form and it is a first order linear differential equation, ordinary differential equation in y. To solve such a differential equation, we first find its integrating factor. The integrating factor is given by e power integral p of x dx. Then we give the general solution. The general solution is given by y into integrating factor is equal to integral q of x multiplied by integrating factor integrated with respect to x plus c. So let's get back to our differential equation, and in our case p of x is e power x into x square minus 2, q of x is equal to x square minus 2x into x square minus 2 into e power 2x. To solve this, we first find its integrating factor, that is equal to e power integral px dx, that is equal to e power integral p of x in our case is e power x into x square minus 2 with respect to x. I will show you the integration in this box. Integral of x square minus 2 into e power x dx, and we consider x square minus 2 as our first function, e power x as the second function. We apply the integration by parts. First function into integral of the second minus integral of the derivative of the first function multiplied by the integral of the second function, then with respect to x. So this will be equal to x square minus 2 first function into integral of the second function e power x dx minus the integral of the derivative of the first function, that is 2x, into the integral of e power x is e power x only with respect to x. And this will be x square minus 2 into e power x minus 2 times integral x e power x dx. Again, we use the integration by parts for the integral of x e power x dx. So, after applying the integration by parts for this integral x e power x dx, then we get this one. Then, after the integration, we get this, and minus 2 e power x and minus into minus plus 2 e power x, they cancel, and we get x square minus 2x in brackets into e power x after the integration. Let's get back to our question. That is equal to e power, that integral is x square minus 2x into e power x. Yes, that is the integrating factor. Now, the general solution is given by y into the integrating factor is equal to integral of the right hand side function, that is q of x into integrating factor with respect to x plus c. Now, substituting for the integrating factor, y into e power x square minus 2x into e power x is equal to integral q of x into integrating factor plus c. Agreed. We continue the discussion in the next slide. That's our general solution, where c is a constant of integration to be evaluated with the given initial condition. And now, this integral, what is this integral? The integral is to be evaluated. For this, we have taken e power x into x square minus 2x, this one, that is the e power of this one, we put it as u. Now, differentiating the first function e power x into derivative of the second 2x minus 2 plus the first function x square minus 2x into the derivative of e power x is e power x with respect to x is equal to du. And simplifying, we get x square minus 2 into e power x dx is equal to du. So, you will see these things, x square minus 2 here, and e power x is to be taken, one e power x is to be taken from e power 2x, and the other e power x we will push it to x square minus 2x into e power x. So, that will be equal to integral of x square minus 2x into e power x. This e power 2x is split into e power x into e power x, that e power x we have written here, and e power x square minus 2x into e power x into x square minus 2 into of and e power x. One e power x has come with respect to x plus c. And we know this red one is du, and the blue one is u, and e power u is also there. So, that will be equal to integral u e power u, this is du plus c, and this is a standard integral u into e power u is u minus 1 into e power u plus c. Substitute for u, then you will get x square minus 2x into e power x minus 1 in brackets into e power x square minus 2x into e power x plus c. So, that is our general solution. Thus, the general solution is y, which is a function of x, y of x into e power x square minus 2x into e power x is equal to whatever we got here, that we have written here. Now, to evaluate this c, we are given an initial condition, that is y at 0 is equal to 0. That is y, the value of y is 0 when x is equal to 0. So, put y is equal to 0 and x is equal to 0 in the above equation, above general solution. We get y at 0 into e power, this is 0, e power 0 is 1 is equal to, this is 0, x square minus 2x is 0 for x is equal to 0, e power 0, 0 into anything is 0, minus 1, this is minus 1 into, this is e power 0 into 1 plus c. So, y at 0 given to be 0, that is 0 is equal to minus 1 plus c, that is c is equal to 1. Now, take this c is equal to 1 and substitute in the general solution, we get the particular solution. What is a particular solution? The particular solution is a solution which is obtained by taking the particular value for the arbitrary constant. So the particular value c is equal to 1 in this, therefore the general solution now becomes particular solution. Now this multiply throughout by e to the power of minus of x square minus 2x into e power x, then you will get y of x is equal to x square minus 2x into e power x minus 1, and you have divided by this, plus e to the power of minus x square minus 2x into e power x. Now put x is equal to 2 to get the value of y of 2. That's what is to be found. So put x is equal to 2, then y at 2 is equal to 2 square minus 2 into 2, this is 0, minus 1 plus e power, this is 0, e power 0 is e power 0. So that is 0 minus 1 plus 1, and minus 1 plus 1 cancels and we get 0. So the value of y at x is equal to 2, that is y of 2 is 0. Let's look at our options. Our answer y of 2 is equal to 0 appears against option C. Therefore, the answer to this question is option C. That is the detailed discussion of the solution of the problem from the section differential equations. It is definitely take a longer time, and unless you are very good at integration, this question may be little difficult. But however, for JEE aspirants, the integration is easy for them because they are perfect in making integrations. So that is the detailed discussion of the solution of the problem from the section differential equations. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.